Well, we're back here looking at problems in gases and moles. Skill practice 36, and I've already started part of the first problem here, and this is using the ideal gas laws. And we're looking at, we got a scuba tank where a diver's wearing that, and he's under a certain pressure and temperature. So we're going to see, we're just looking for the number of moles. We can use the standard PV equals nRT. Anytime you got anything with grams in it, when it's asking you either for molecular mass or the mass of the gas, we talked about where number of moles is really the mass divided by the molecular mass. And then I just cross multiplied and made it just a linear equation here. Alright, so I started this. We got pressure 394, volume of 2.1. We're looking for the number of moles. We know the gas constant is 8.31, and we converted our temperature to Kelvin, so that's 290. So we can go ahead and plug that into the formula. So 394 times 2.1. We're looking for the number of moles. R is 8.31 and a temperature of 290. And if my math is going to be correct here, we're going to have N equals 0.34 moles. And we've got, again, we're looking at number of sig figs, 3232, so our answer has to be in 2 sig figs. Alright, let's look at B. I think I'm going to do it right below here. It says if the diver swims to the surface without exhaling, where the temperature is 32 and the pressure changes to 100.2, what will the volume of air in his lungs be? So really we're going to use some of the information from the previous problem also. So let's go ahead. We got pressure, and that's going to be 100.2, and volume we don't know, and we got from the previous problem, so that's 0.34. R is going to be 8.31 because we're doing a kilopascal jet, and temperature is going to be Kelvin equals C plus 273. Push that up a little bit. And so we said C was 32 plus 273, so that should come out to be 305. Okay, so we can use PV equals nRT as we did up there. So P is 100.2. We don't know the volume. N is 0.34. R is 8.31. And temperature is 305. And hopefully my math is correct here. We would expect our volume to increase because we're moving up on the surface, not under all that pressure. And let's see, with our volume here, 2.9 liters. If we do our math here, again, number sig figs, looks like we have 2 here, so our answer can have 2. So there's what it is as the diver surfaces. Let's look at problem number 3. On planet X, 2.78 moles of gas takes up 1.85 liters under pressure and a temperature of 201 C. What's the value of R on this particular planet? Well, PV equals nRT. And so that's asking for R, so we know the pressure. So we got P. We know the pressure on this one's 74.1. We have a volume of 1.85. We know how many moles, 2.78. And R is what we're going to look for. And the temperature, it's still That's still in Celsius here. So we know Kelvin equals Celsius plus 273. So this is 201 plus 273. Should come out to be 474. So let's go ahead and do the math. Pressure 74.1, volume 1.85. We have 2.78 moles. We don't know R, and we have temperature 474. So the math is pretty straight. Multiply these two, divide by this quantity here, and R comes out to be 0.10 is what R is. And if you can go back and look up the units of that, but the gas constant is going to be 0.10. And number sig figs, actually we could go, we got 3, 3, 3, and 3, so we could say it's 0.100 on that. Alright, that's problem 3. Let's look at problem number 4. And at a pressure of 103 kilopascals and temperature 22°C, 52.9 grams of a certain gas has a volume of 31.5. What's the identity of this gas? Well, right away we've got something in grams. So we're going to need to use really the secondary formula of the ideal gas law, which is the molar mass, pressure, volume, equals the mass of the gas, gas constant, and temperature. So we want to find the molar mass. So we don't know that. Pressure, we have 103. Volume, we have 31.5. M, we have 52.9 grams. R, seeing we're using kilopascals, is going to be 8.31. And our temperature, again, Kelvin equals Celsius plus 273. So that's 22, down a little too much, plus 273. And that equals 295. So we can plug in. So M, pressure 103, volume of 31.5. We have 52.9 grams. R is 8.31. And the temperature is 295. So M is going to equal 40, if my math is correct. And if you look on the periodic table, you'll find that this is the mass for the gas, argon. If you look on the periodic table, you'll find that. Alright, so I'm going to do problems 5, 6, and 7 in the next video.